Hello and welcome you all to this second video on permutation and combination under the topic of number theory. We will be solving problems of permutation and combination in this part 2 video. Please refer to the part 1 video for the basic definition as well as basic concepts of sum and product rule and the laws for repetition and circular arrangements. Now we will move on into problem. Problem number 1. Assuming that a repetition are not permitted, how many 4-digit numbers can be formed using the 6 digits 1, 2, 3, 5, 7 and 8? Totally we have 6 digits and what we have been asked to form is going to be a 4-digit number. So I have 1, 2, 3, 4. 4-digit number. So this first position can be filled with one of these 6 digits in how many ways? That can be done in 6 ways. And now one number has gone if we are fixing it here. And now this second position can now be filled with the remaining 5 elements in 5 ways. Next, the third position can be filled in 4 ways. And the last one can be filled in 3 ways. So totally the 4 digits which we require can be formed in the number of ways will be equal to 6 into 5 into 4 into 3. This is the number of ways in which I can form a 4-digit number without any repetition from the given 6 digits. This can also be done as from 6 you're going to arrange 4 elements. It is arrangement. Hence we use permutation because when I arrange I know that the element 53 is not the same as 35. So arrangement is going to be different for me when I shift the positions. So always keep in mind arrangements means it is going to be permutation A with P, and when you are going to be picking then it goes with combination. So now we are going to arrange, hence we need to concentrate on permutation. So out of 6 I am going to arrange 4 elements. So it is the same as 6P4 which can be estimated using the calculator as 360. So this is going to be our final answer. Now second subdivision, how many of these numbers which we form are going to be less than 4000? So I have a 4-digit number and this 4-digit number has to be less than 4000. Less than 4000 means I need to concentrate on the first box. This first box can be filled with one of the numbers either 1 or 2 or 3, in which case the number which I get formed will be automatically less than 4000. So this first box can be filled in 3 ways. Now coming to the remaining boxes. Now out of the 6 digit, 1 digit has gone and the remaining 5 digits are going to be there. And how many digits I need? I need 3 numbers out of them. Now this can be picked in 5 P 3 ways. So now the total number of ways will be the first digit that can be done in 3 ways and the remaining 3 digits that can be done in 5P3 ways. So the total will be, whenever you have and, you will have to multiply. Keep this in mind. So this is what you call it as product rule. So it is 3 into 5P3. This 5P3 can be estimated using your calculator, and when you multiply it with 3, your final answer will be 180. Now moving on to the next set of subdivision. How many of the numbers in your part A is going to be an even number? Now I have 4 digits and I want the number to be formed to be even. What do we mean an even number? If this last digit is going to be a multiple of 2, then we call that number to be an even number. Now we can see that out of the given elements, which are going to be multiple of 2, 2 is a multiple of 2, 8 is a multiple of 2. So I can fill the last digit with either 2 or 8. So there are going to be totally 2 ways in which I can fill the last element. And now for filling the first 3 element, out of the 6 digit, 1 digit has been used. So I have 5 digits which is being left out, and out of which I need to pick 3 out of them. So that can be done in 5p3 ways. So totally the last digit can be fixed in 2 ways and the first 3 digits can be fixed in 5p3 ways. You have an AND, which means the final answer is 2 into 5p3. Compute this using your calculator and multiply with 2 to show that the final answer is 120. Now, how many of these numbers are going to be odd in nature? So, what do we mean by an odd number is the number over here must not be a multiple of 2. What are going to be the odd numbers that can be given to us? 1, 3, 5, 7 are going to be odd numbers. So I can 1, 3, 5, 7 are going to be the numbers that can fill the last digit, in which case the number generated will be odd. So how many number of ways I have for filling the last digit? I have 4 ways for filling the last digit. And the remaining 3 digits can be filled using the 5 digits which is available in how many ways? So you need to pick 3 from the 5. That can be done in 5p3 ways. So since it is an AND, it is 4 into 5p3, the total number of ways. Total number of ways will be equal to 4 into 5p3, and we can show this to be equal to 240. Now the next subdivision being, how many of the numbers in part A are going to be multiple of 5? What do we mean by multiple of 5? If the last digit is going to be either 5 or 0, then you call it to be multiple of 5. We don't have a 0 in our case. The only element available for us is going to be 5. So if the last element is going to be 5, then I can fix this number always with 5. In how many ways I can fix it? In only one way. So now the remaining 5 digits can be used for these 3 boxes, and you can do it in 5p3 ways. Now the 5p3 into this one way in which your last box has already been fixed with 5 can give you the final answer to be equal to 60 ways. Now comes the last part. How many of the numbers must contain both the digits 3 and 5? Now out of the 4 boxes, what happens? I am fixing 2 numbers. One is going to be 3 and the other one is going to be 5. So 2 positions are fixed out of the 4 boxes. Out of the 4, how I can fix 2 positions? I can do it in 4p2 ways. So 3 and 5 can be fixed in 4p2 ways. Now if 2 places have been occupied by 3 and 5, then how many digits we had? We had 6 digits, and then 2 has already gone. So how many we have? 4 digits are left out with us, and 2 places have already been filled, and out of the 4, how many places will be left out? 2 places will be left out. So using the 4 digits, I can fill the 2 places again in 4p2 ways. So the remaining position can be filled with 4 elements, and 2 places can be done in 4p2 ways. So both of them combined together can be done in how many ways? So this is 4p2 into 4p2. So that becomes equal to 4p2 into 4p2. So 12 into 12, that makes it as 144 ways. I hope the first problem about how we arrange elements using permutation is going to be very clear to you. We move on to the next problem. How many positive integers n can be formed using the digits 3, 4, 4, 5, 5, 6, 7 if n has to exceed 50 lakhs? Now, the problem in number 1 was all the elements were distinct for me. But now in this case, I have elements in which 4 is being repeated twice, 5 is being repeated twice. So, we have repetition of elements. So whenever we have a repetition of elements, we need to keep in mind that what happens is like the pepper problem, the total number of ways that is going to be your n factorial has to be considered, and you will have to divide it by the number of repetition, n1 repetitions, n2 how many times it is repeating, n3 how many times it is repeating, and so on. So this is going to be the rule for repetition. So now I need a number to be of how many digits? 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 7 positions I am going to have. This 7 positions I am going to fill using how many elements? I have 1, 2, 3, 4, 5, 6, 7. 7 digits I have. So 7 spaces with this 7 digits I am going to fill it up. The criteria is it has to exceed means more than 50 lakh. If it has to exceed, it has to be more than 5 or more than 5. So the last digit, the first digit over here can begin with 5. So you will have to exceed 50 lakh. If it begins with 6, then also it exceeds 50 lakhs. And if it begins with 7, then also it is going to exceed 50 lakh. So you have case 1, either this, or case 2, it can begin with 6, or you have a case 3 in which you can begin the first digit with 7. So say suppose you are beginning the first digit with 5. So out of this elements, 1 5 has already been fixed, and now I need to fix 1 2 3 4 5 6 positions using 1 2 3 4 5 6 digits. 6 positions, and I have 6 digits in which some of them are going to be repetiting in nature. So the number of way is going to be 6 factorial divided by the repetitions now, which is getting repeated over here. The element 4 is getting repeated 2 times. So 4 repeats 2 times. So I have that to be divided by 2 factorial. See, notice I am not taking 5 into consideration because 1 5 has already been fixed over here. So apart from that, only one independent 5 is available for me to occupy this position. So that will not come under repetition. Okay, keep in mind. So only 4 comes under repetition. So we have 6 factorial divided by 2 factorial. In which case, this is going to be equal to 360 ways. So now coming to the case of 6, and then the first letter is going to be fixed with 6, and then you have 1 2 3 4 5 6 remaining spaces. So now for the case when I have this to be fixed with my 6, so now what will happen over here? If I am going to fix it with 6, then I have the remaining 6 places that can be occupied by 3, 4, 4, 5, 5 and 7. So you have 6 position and 6 digits that can be done in 6 factorial ways. When I fix 6, there is going to be 4 that going to repeat 2 times, and there is also going to be 5 that is going to repeat 2 times. So I'll have to divide it by 2 factorial for 4 that repeats 2 times, one more 2 factorial for 5 that repeats for 2 times. So this now totally gives me 6 factorial by 2 into 2 factorial into 2 factorial. So that makes it as 180 ways. So now coming for case 3, when the element is now going to be fixed with 7. So again, when the first element is 7, and I have 1, 2, 3, 4, 5, 6 remaining boxes. Then how to handle the case? So which is the number I am fixing here? I am fixing it for 7. 7 is the digit getting fixed. So the remaining 6 position can be filled with this remaining 6 numbers. So in how many ways I can do that? I can do it in say 6 factorial ways, and again I have 4 to repeat 2 times when I fix 7, so it is 2 factorial, and I have 5 to repeat 2 times, that is going to be again 2 factorial, so it is going to be 180 ways again for me. So the total number of ways in which this can be represented is either with 5 or with 6 or with 7. So whenever we have or, we go for the sum rule, which says that the total action can be done in the addition of ways. So we have the total number of ways to get a number which is exceeding 50 lakh to be equal to 360 plus 180 plus 180. So this is going to be my total number of ways, and I suppose this adds up to 720 ways. So please do check this up so that we will get comfortable with it. Now moving on with the next one. I have a club that consists of 6 men and 7 women. In how many ways we can select a committee of 3 men and 4 women? First we will move on with the first question. So it is going to be a club, so it is totally containing how many men over here? You have 6 men, and then you are going to have 7 women, and you are going to select. Select means pick. Pick means see your combinations. Okay, so the operator we are going to use in this problem is going to be a C. I need 3 men from 6 men. So in how many ways I can do it? I can do it in 6C 3 ways. There is an AND operator in between, so I'll have to put a multiplication sign over here. 4 women from 7 women, so it is 7C4. So I can do a 6C3 multiplied by 7C4. So that will totally make the number of ways to be equal to 700 ways. So we will move on with the second subdivision where I want 4 persons. Okay, I am going to choose 4 persons over here, and out of which at least one of them have to be women. So I am giving preference. The first one is going to be women, at least one, in which case what will happen to the remaining cases? The remaining is going to be men in all. Men, men, men. Or it can be the case that I have, that is at least one. So at least means one and more than one. So I can have 2 women and the remaining 2 be men. Or you can have the third case where we are going to have 3 women and then you can have 1 man. Notice the restriction is going to be at least 1 woman, so 1 or more women. So there is no restriction on women. The only thing is that we cannot count on men. So we can also include the last case over here where the team or the selection can be chosen for all of them to be women. So these are going to be the various ways, or. So whenever I have an or, what you will have to do? You will have to add the data. So now coming to the case 1 over here, when I have 1 woman. So 1 woman from 7 women. So it is going to be 7C1. And you need remaining 3 to be men from 6 men. So it is 6C3. So it is 7C1 into 6C3. So that is going to make it to be equal to 140. The next case where I have out of 7 women, I choose 2 women. So it is 7C2, and I have 2 men from 6 men. So it is 6C2. So and means you will have to multiply, or means you will have to add. So this and multiplication will give me equal to 315. The third case, when I have 3 women from 7 women, 7C3, and you have 1 man, so 6C1, so that is going to make it as 210. And the last case where you have all of them to be women, 7C1 4, and you have no women, no men, 6C0, so that makes it to be equal to 35. So you add up all the data because it is or. So either this can happen or this can happen, and this can happen or this can happen, in which case all of them are going to be like at least one woman is present. So the final answer is going to be equal to 700 ways. Now the third case where you have at most one woman. So what do you mean by at most? At most means it's going to be max one woman can be there. Okay, so out of the 4 boxes, maximum one woman can be there, So what is going to be the criteria now is going to be that for men. So what happens over here, I can have that to be equal to 1, at most 1 women over here. Okay, at least 1 woman over there. So you can have it to be equal to 1 woman and all the remaining 3 to be men. So 1 woman from how many of our women? 7 women. That can be done in 7C1, and the remaining are going to be men, so it is 6C3. Or what is going to be the other case over here? At the maximum 1 woman was only allowed. So there can also be the case that no women is present, in which case all of them are going to be men. So I have totally 6 men, and out of the 6 I can choose all of them to be 4, and out of the 7 I choose no women. So it is going to be the combination of both of them. So you just add it, so you will be getting your answer for the third subdivision. In which case we have the answer for the first one to be equal to 140 and 15. So that's going to make it to be equal to 551 and 155. So the last subdivision what we had over here was 4 persons that has persons of both gender. So which means that the last one has 4 boxes, and I need to have at least one of them to be men and one of them to be women. So if this is going to be fixed, then I can have 1 man, and then I can have 3 women. You can have 2 men and 2 women, or I can have 3 men and 1 woman. So in this combination, I will have the capacity of the committee or the selection to have both the genders together. So these are the combination, in which case if I am going to work, it is going to be 6C1 into your 7C3, the first case, plus the 6C2 into the 7C2, the second case, plus or everywhere. Or means add. Okay, your 6C3 into 7C1, the third case. So go on with it, and then when you multiply, you will have it to be equal to 210 plus 315 plus 140, which adds up to 665. So this completes the problem over here. Next, moving on with the circular arrangement. I have 6 people A, B, C, D, E, F who are seated around a table. In how many different circular arrangements are possible? If the arrangements are considered the same, when one can be obtained from the other by rotation. So no clockwise and anti-clockwise distinctions are being made. So 1, 2, 3, 4, 5, 6. So along the circle, 1, 2, 3, 4, 5, 6. 6 people are being made to sit. So there are going to be n different objects. So there are going to be 6 different objects for us, and the number of ways in which we can arrange is going to be 6 minus 1. So it is going to be 5 factorial, and it is going to be 120. In the next case, if A, B, C are going to be female and the other are going to be male, in how many arrangement do the sexes alternate? That is, I can make them sit as male, female, male, female, male, female, and so on. Okay. So since rotation does not alter the circular arrangement, we can assume that the first position is being occupied by A, which is going to be a female. So I have totally 1, 2, 3, 4, 5 positions left out because totally 6 of them are there. In the first one, if I am going to fix it as female, the second one will become male. The third one will become female again, a male, a female, and a male, and then will be a female. So totally I have how many, if this position of A is fixed, now I have 5 people left out, and I have this to be female, this to be female, 2 places for female that has to be filled up with, and I have this to be male, this to be male, and this to be male that has to be fixed up with. So of the remaining places, position 1, 3, 5 must be filled by 3 males. This can be done in how many ways? 3 position by 3 males, 3 position, 1, 2, 3, 3 position by 3 males. So I can do it in 3p3 ways. And now out of them I have this remaining 2 places, position number 2 and 4, which can be occupied by 2 females. And how many ways I can do it? 2p2 ways. So the total number of arrangements will now be 6 into 2. So that is going to make it as 12. So this place can be done in 3p3 ways, and the remaining 2 can be done in 2p2 ways. And so the total arrangement will be the addition of both of them together. So that makes it to be equal to 6 and because both this and this, not an or, so this is going to be and, so this is going to be 6, and this is going to be equal to 2p2, which is going to be equal to 2. So we have this to be 6 into 2, so it is going to be 12 ways. So keep it in mind, the sum and the product rule. Whenever you have and, go with your multiplication, and whenever you have or, go with your addition. So this is going to be the base for any of your problem. Keep this in mind and things will become very easy. So keep in mind, whenever it is picking, it is combination. When it is arranging, it is going to be permutation. A goes with P, AP, C is going to be for your P is going to go for picking, is going to go for your C. Okay, combinatorics. A arrangement going with permutation, and picking or selection goes with combinatorics, combinations. So keeping these simple things in mind, permutation or combination can be very easy to work for. Happy learning, keep learning. Thank you very much.